This video from our arithmetic chapter is on multiplying and dividing fractions. So if you look at the top, I thought I would show you exactly what it means when we multiply two fractions. So if I say 1/2 of 3/4, that's the same thing as saying 1/2 times 3/4. So of means times. So let's look at on this little sketch what that means. So here I have a bar divided into fourths. If I talk about 3/4, I would shade 1, 2, 3 of those fourths. That gives me my 3/4. And now I want to talk about half of that. So with a different color here, let me try to divide this so you can see it. Ignoring the one on the end that's not shaded, if I wanted to divide these three into half, it would be right about here. And then I have the problem of being able to name them. What do I call those pieces? Because they're not all the same size. So if I divided all of them so that they were the same size, including these, I could then rename them as 1, 2, 3, 4, 5, 6, 7, 8. So each one of those is 1/8. And in my half of my 3/4, I have 1, 2, 3 eighths. So half of 1/4 is 3/8. Now you don't want to have to draw every time that you have to multiply fractions. So we want to look at arithmetically what really happened with the numbers. So I think you can see that what we actually did was multiply 1 times 3 and get 3, and then 2 times 4 and got 8. But I don't want you to think it's some kind of magic. That's why I wanted to show you what it really is and what's really happening when you multiply fractions. So here there's a general rule. If you have a fraction a over b and you are multiplying it times c over d, then what that is equal to is a times c over b times d, whatever those numbers are. So let's try a few. Here I've got 2/3 times 5/11, so it's 2 times 5 over 3 times 11, or 10 over 33. Now this next one is a little bit different. I could go ahead and multiply 6 times 14 and get 84, and 7 times 27 and get some, I think it's 189. That's a really large number, and I'm not going to be able to tell just by looking at it if it can be simplified. So let me show you a way that you can simplify before you multiply. It's called cross canceling. You can only do it in multiplication. You cannot do it, I'm putting equals multiply. You cannot do it in addition, subtraction, or division. And what you do is, rather than simplify the fraction at the end, you simplify first by looking at crosses and seeing if there is anything that will go into both numbers. So is there anything that goes into 7 and 14? Yes, it's 7. So 7 goes into 7 once, it goes into 14 twice. Is there anything that goes into 6 and 27? Yes, 3. 3 goes into 6 2 times, 3 goes into 27 9 times, and now it's kind of messy. You multiply what's left. So 2 times 2 is 4, 1 times 9 is 9, and we end up getting a simplified version of what we would have had we multiplied the original. I wouldn't begin to know how to start what to divide into this. So sometimes it's easier if you can cross cancel first and get 4/9. By the way, if you do your cross canceling correctly, the fraction that you get should be completely simplified. All right, let's look at example 3. We have a whole number here and we have a number with a variable. So the first thing I'm going to do is I'm going to rewrite that by putting my whole number over 1. You can always do that with whole numbers because division by 1 doesn't change the value. Now I'm going to cross cancel if I can. 3 goes into 3 once, it goes into 6 twice. It doesn't matter that there's an x there. It doesn't change a thing. And what we have is -2 times 2, which is -4, and then we have an x over, notice I didn't draw the line really because all I have left is 1 times 1. Now I could put that, but it's the same thing as just negative 4x, so there's no reason to show that 1. Looking at the next one, you're going to see that I have 2 variables. So let's see how the cross-canceling works here. 4 goes into 4 once, it goes into 8 twice. 3 and 5 don't have a common factor other than 1, but x goes into x one time and x goes into x one time. So those make 1s also. The variables cross-cancel. And now what's left is 3 times 2 is 6 over 1 times 5 times 1, or 5. And notice I am leaving my fraction as an improper fraction rather than changing it to a mixed number. In algebra, the improper fraction is much easier to work with than is the mixed number. All right, in example 5, all we have are variables, no numbers. So how does the cross-canceling work? Well, for now, what I want you to do is expand the exponents. So x squared is x times x over y. Y cubed is y, 3 copies of y, over x. And now we can cross-cancel those variables. So y cross-cancels that y. This x cross-cancels one of those, and we have to carefully look at what's left. There's an x, y, which is xy squared. The only thing left in the denominator is 1, which we didn't show, so we don't need to show it in our answer since it's over 1. All right, let's look at evaluating expressions. Here I have fractions that have been raised to a power. Now there's 2 ways to think of this. The first way to think of it is it's 4 copies of 2/5. And so I can write it like that. And then nothing will cross cancel. So I have 2 times 2, 4 times 2, 8 times 2 is 16 over 25 times 25, which is 625. That's one way to think of this. The other way to think of this is, since the exponent is outside the parentheses, it belongs to everything inside. So it's 2 to the 4th over 5 to the 4th. Now it comes out the same. This means 2 times 2 times 2 times 2 over 5 times 5 times 5 times 5. Whoops, 625, sorry. And you get the same answer either way. I tend to think of it this way, but it's perfectly fine to do it like this. This one, the 2 on the outside of the parentheses means the negative 1/4 is being squared or multiplied times itself. So negative 1 times negative 1 is positive 1. 4 times 4 is 16. So we ended up with a positive because we were squaring a negative. All right, let's look at the next page. Let me bring this back down. And we're going to look at dividing fractions. Dividing fractions is very easy because you don't really divide, you multiply. So let's look at how it works. We talk about the reciprocal. 2 numbers are reciprocals of each other if their product is 1. But an easier way to think of it is, it's the fraction flipped. So if you have the fraction a over b, its reciprocal is just b over a. And the reason is, if I multiply those, I get a times b over b times a. Everything cross cancels and you're just left with a 1. Every number has a reciprocal except for 0 does not have a reciprocal. So let's look at what division of fractions really means. And I'm not going to draw this like I did with multiplication. It's kind of a difficult thing to visualize. But 3/4 divided by 1/8 means how many 1/8 are in 3/4. I mean, so I could draw that. Most of the time it's too difficult to draw. So this is what you really do with those numbers. We keep, change, and flip. So you keep the first fraction, a over b, as it is. You change the division sign to multiplication, and then you use the reciprocal, so you flip the second fraction. So c over d becomes d over c. And then you just follow the rules for multiplying, which is cross cancel if you can, and if you can't, you just multiply. So let's try one. 5/16 divided by 3/4 means keep, change to multiplication, flip to the reciprocal. Now that we are multiplying, we can cross cancel. 4 goes into 4 once, it goes into 16 4 times. The 5 and the 3 will not cross cancel. And so we end up with 5 times 1 is 5 over 4 times 3 is 12. And that's the answer to the original division problem that we did with multiplication. B, I have negative 7/12 divided by negative 5/6. So I'm going to keep, change to multiplication, flip. Now when you flip this fraction, the negative sign can stay in the middle or it can stay on the top or the bottom. It doesn't matter because it's all going to be the same. I usually keep it on top, so I'm going to flip this and keep the negative up there. But again, it doesn't matter. Can we cross cancel? Yes. 6 goes into 6 once. It goes into 12 twice. Now we have negative 7 times negative 1. The negative didn't cross cancel. That gives me a positive 7 over 2 times 5 is 10. So just be careful when you cross cancel. Don't drop off those negatives. All right, divide and simplify. Here I have a whole number, so the first thing I'm going to do is put it over 1 so that I can see what its reciprocal looks like. So I keep the first, change to multiplication, flip to the reciprocal of the second, and at the same time I'm going to take the x squared and write it in its expanded form, x times x. Will anything cross cancel? No, you cannot cross cancel those 3's. Cross means one numerator, one denominator. So no numbers will cross cancel, but this x will cross cancel one of those. So be careful. I kind of black them out like that so I can see what's left. What's left in the numerator is 2 times 1. What's left in the denominator is 3 times x, 9x. Make sure you make it abundantly clear that that x that's left in this case is in the denominator. It matters where it goes. It has to go where it actually remains in the problem before you multiply. All right, let's look at one that has more than one operation. It says simplify. Well, before I do keep, change, flip, I have to do what's in parentheses. And can I cross cancel there? Yes, I can. 4 goes into 4 once, it goes into 8 twice. So in the parentheses, I have 1 times 3, 3, 7 times 2, 14. Now I'm going to recopy the rest of the problem. Notice I removed the parentheses since there's only one fraction in it, kept the negative sign in the numerator. Now I'm going to keep, change, flip. So 3/14, change, flip the fraction. I'm going to keep the negative in the numerator, but it doesn't matter if you want to flip the negative 2 and keep it with the 4. Keep it in the with the 3 in the denominator. That's okay. Cross cancel. 3 goes into 3 once. It goes into 3 once. What will go into 4 and 14? 2. 2 goes in there 7 times. It goes into 4 twice. So I have 1 times negative 2 is negative 2. 7 times 1 is 7. By the way, let's look at this fraction. I just want to remind you of something. Negative fractions can be written like this. Negative 2 over 7 or 2 over negative 7. That's not as common, but it means the same thing. It's still a negative fraction. Or negative and then 2 over 7, where the negative is out front. All right, looking at the next page, we're going to look at some applications. So the first one says, if x equals 7/8 and y equals negative 1/3, evaluate x times y and then x divided by y. So two problems. So let's do x times y first. That's what it means when it's written side by side. That would be 7/8, that's our x, times our y is negative 1/3. Nothing will cross cancel, so we just get negative 7 over 24. So this is the multiplication one. I just wrote multiplication over there. Let's now do division. X divided by y would be 7/8 divided by -1/3. And we know that we keep, change, flip to the reciprocal. I kept my negative sign. That's going to give me nothing. We'll cross cancel. -21/8. And I'm going to leave that as an improper fraction. So I got very different answers when I multiplied and when I divided. The next question is worded kind of oddly, so I want to make sure you understand what it means. It says, is -2/3 a solution of this equation? Well, what that means is if I take -2/3 and I put it in the place of the x, will it equal 1/3? So let's try it. -1/2, take out that x, put in -2/3 in its place. Is that equal to 1/3? Well, the parentheses there are just a separator, so I can still cross cancel since I'm multiplying. 2 goes into 2 once, it goes into 2 once. I've got -1 times -1 is +1. 1 times 3 is 3, and 1/3 does equal 1/3. So yes, -2/3 is a solution to that equation. Last problem I put on so you would be able to determine if you needed to multiply or divide. It says Cedar Point is an amusement park located in Sandusky, Ohio. Its collection of 68 rides is the largest in the world. Of the rides, this is a very important word here. We talked about it at the beginning of this lesson. Of the rides, 4/17 are roller coasters. How many roller coasters are in Cedar Point's collection of rides? Well, we know it's going to be a whole number, and it's got to be less than 68. So I'm going to turn this sentence around. I'm going to write 4/17 of the roller coasters, of the rides are roller coasters. So let's see if we can put in some numbers for some of these words. So 4/17. We said earlier that of means multiply. Rides, we know how many rides there are. It told us 68/1 equals the roller coasters. This actually cross cancels. Some of you may not realize that, but it does. 17 goes into 17 once. It goes into 68 4 times. So I'm left with 4 times 4 is 16/1, or 16 rides are roller coasters, which makes sense. That's less than 68. It's even less than half, and 4/17 is less than half.